everybody. This is Talking Digital Industries, a deep dive on technologies and trends which drive industrial enterprises. And all of this brought to you by Siemens. I'm your host, Christine Brunner, and in today's episode, we are focusing on edge computing in drive technology and how you can use drive data most efficiently. So everyone is talking about data, which is said to be the new gold. Heaps of data are available, but which data from the machine do we need? And what role do they play in this game? Let's find out with our experts who are joining us today, Michael Leipold and Dominik Bittner. Both of them are known warriors when it comes to communicating and presenting their projects and solutions at our fairs and events. Michael is working at Siemens Digital Industries, and he's the project lead for digitalization of motion control drive technology. Welcome, Michael.
Hi, Christine. Thanks for having me and giving me the opportunity to talk about edge computing and the drivetrain in manufacturing and process industries.
It's a pleasure, Michael. Always fun to discover new facts through your presentations. Now, let me also welcome Dominik. He's responsible for marketing of industrial IoT applications and artificial intelligence. And when it comes to explaining complex topics, he's our man. We've seen great social media clips with you, Dominik, so I'm very excited that you're joining our round as well.
Hi, Christine. Hi, Michael. Thanks for having me here and also giving the opportunity and maybe explaining complex or not so complex things also today. I'm looking forward.
Looking forward to that too. Great you're here with us. This will be a fun round for sure. Well, me and of course our listeners are very curious to learn more about what our customers can do to extend their business with the help of digitalization. The overall world is looking for digitalization solutions, and I'm really looking forward now to this discussion. So let us now dive deeper into our topic. First of all, I would like to know more about the general industrial context. Why do we need edge computing?
Actually, edge computing is relevant in each and every industry sector, Christine. So it's not something that is very, very solution or very vertical specific. No, it is something that can be used very broadly. Especially if we have a focus around production machines. We see that there are mainly three trends upcoming in the future. First of all, we find out, and also our customers are at this point, that the increasing demand for smart and intelligent data processing is getting more and more and more. Second, another big trend that is not just a trend in our private life, but also in the industry, that actually the amount of devices and smart assets is also growing day by day. And last but not least, the need for actually faster and more flexible machines, as well as adding new features. This is also a trend where edge computing is, in my opinion, the perfect tool to serve exactly these challenges. And that's the reason why everybody in the industry needs edge computing.
Mm-hmm. I mean, I can't agree more to having more and more of those smart little helpers, but to coordinate them and all bring them to the same level is also kind of tricky. And I think you need special know-how. But talking about know-how, who in industry uses edge computing? Can you describe a bit more detailed which targets can be achieved with it by our industry specialists, Dominik?
Well, actually, with edge computing, Christine, we are addressing end users like machine and plant operators, service technicians, but also we address machine builders. So actually, the complete portfolio and the whole offering of people working with machines, building machines, they are facing challenges. The first challenge, this is something where actually we as persons have a big impact on. This is the increase for flexibility, other products, different products. Because we want to have sneakers in every color with every type of of text on it with our personalized names. We want things differently. And this is a challenge for industries. Second thing is that the increase of quality or a stable quality level is very crucial for these guys. It's crucial for plant operators, for machine operators, but also as well as for machine builders. And this also lets them that they need to have a better productivity and increased productivity. And of course, on the other side, they want to reduce their costs. They want to reduce their costs for production, for operation. And last but not least, we see that the factories, they always need to have an increased outcome. So having more outcome for the same input, so to say.
That's a big wish list, Dominik, and I'm not sure if it's that easy to accomplish. So, Michael, what's your stake here?
I mean, that were very good points Dominik was making. And I think it became very clear that all those, as you call it, wish list and all these features that both machine user and machine builder are facing alike, in order to really accomplish these, in order to leverage these use cases, we need, or they need, to understand not only the machine as such, but the machine in total. We need to understand all the assets, all the components within the machine in order to get that overall understanding. And if we look at the different components within a machine, the drivetrain is making up for a very, very focal point in that. I mean, if you look at the energy consumption of a typical production machine, the overall energy consumption, 70% out of that is being consumed by drives. So whenever 70.
Wow.
I mean, you have to bear that in mind. So that means only if you do understand the drivetrain and the respective components in your machine, you get the comprehensive understanding, the big picture of your machine and its health state. Only if you know how your drive systems feel, you are going to understand and get that required transparency. And then you are able to address all those topics that Dominik already mentioned, how to avoid quality issues with the products that you're producing on the machine, or you can avoid unexpected downtimes of the machine, which will, of course, have impact on the end-to-end cost calculation in your production. It's about processing the data and analyzing them in order to be able to impact the overall production process and the required machine conditions. It is, at the end of the day, not that complex, maybe. In most cases, it's really sufficient to monitor the current speed and maybe metrics like torque, that you can detect what's going on in your machine. And getting back to the topic that we're talking about, the industrial edge platform perfectly pursues this approach. It complements our already well-established TIA, totally integrated automation approach, where already as of today, drive systems, Dynamics drive systems, are an essential part of the entire machine.
Yeah, I mean, you're saying not complex, but it's not complex if you know your tools and tricks. It kind of reminds me a bit of a machine whisperer, you know, if you know your machine and all the little hiccups which it maybe brings along, you know which buttons you have to click or what models you have to change. But what are the advantages for the machine operators?
There are actually a lot of advantages. Just maybe to name the most important ones. So first of all, the increase of flexibility in the production. That's basically the sneaker example I had at the beginning. I think the term lot size one is here the cue for the most. So having just this into production, what really your customer wants, and each individual customer wants. The second thing is that you want to increase the availability and therefore also the productivity of your production. Because if you have a machine and you have this machine at your factory, you want to produce 24 hours at best and not having to wait a lot of time because there are downtimes or stuff like that. And I think also another important topic I would like to bring here in is that you also need to identify possibilities for process optimization, because things are good, but they are never the best. And it's always important to improve machines, to improve processes. And I think these are the advantages that machine operators can take with them. But I think we should not only focus on machine operators here. So maybe, Michael, you can also tell us a little bit more about the machine builder part here, or the machine whisperer part.
The machine whisperer part. But I like that analogy. I really do, Dominik. And of course, it's crucial that we not only focus on the machine operators or the users, who are, of course, an essential stakeholder in this whole digitalization story. But we have to bear in mind that the machine builders can bring in all their specific machine and vertical expertise. And this is why I like the picture of the machine whisperer so much. These guys know best how to utilize their machine, where its specific advantages are, and they are the ones who bring in this vertical expertise of how to utilize it best in that specific industry segment. With that, they are able to increase the utilization of the machine, and with that also address the aforementioned motivation of increasing productivity. They are able, by bringing in that expertise, to ensure the reliability of operations with all the already mentioned advantages: reduced maintenance intervals, reducing downtimes, reducing end-to-end wall cost. The analysis of the operational data that are already available in the machine enable them to also address the use case of predictive maintenance, of being able to already see and anticipate possible failures in the machine long before they actually occur, and with that reduce non-conformance cost. It's the challenge, basically, how should I phrase that? It is the challenge not to only provide machine builders with the operational technology, the OT, but also providing them with a comprehensive and integrated IT concept of basically building the bridge between OT and IT world, so that machine builders and OEMs can offer their customers real value propositions and consulting. And based on that, they can also establish new business models based on data-driven services, which bring up all new opportunities for them in the field of maintenance, repair, and optimization, in so-called MRO businesses. I think that is really, really the fruitful and bright future we are looking to, of being able to also address that stakeholders, the machine builders.
Yeah, if it's that easy, it all, as you explain it here, it all sounds great, easy to achieve, quick to realize, but that's all theory. Can you give us a real example? Is it as easy to accomplish, to achieve as it sounds?
Yeah, Christine, the past 2 years clearly showed us the importance, for example, of logistics. I mean, e-commerce had been really supercharged by the pandemic. And so, for example, if we take a look at major postal and package distribution centers as an example, the importance of conveyor technology and hence drive technology in intralogistics basically became apparent to all of us. The consequences and the end-to-end cost of a conveyor technology application failing in such a distribution center that are resulting from the downtimes are massive. And this applies even more to industry than to our private lives, where your cosmetics that you ordered or the sneakers that we already talked about arrived 3 days later.
Tell me about it. I ordered a rowing machine to do some workout at home, and I had to wait incredible 5 months to get it delivered. Reason why? Manufacturing problems, as some parts were missing for production. So at least I've been told. Well, the results of that late delivery were obvious and dramatic too. Weight gain. But let's come back to business now. Couldn't easy solutions for problems like this being provided by a cloud solution? So why do we need edge computing here?
Christine, that's actually a very, very good question that you bring up, cloud and edge. So, ladies and gentlemen, put out your sketch bags. Here comes a quick guide to edge and cloud to answer this question. So let's start with cloud computing. The big benefits of cloud is that you benefit for sure from global data access, plus you have the chance to book your performance on demand. Meaning that cloud is actually quite a good tool for comprehensive long-term data analytics, which should not be mandatory real-time related. So it's mainly about visualizing, analyzing data, monitoring, and also sending out notification. Edge, on the other hand, so there's for me the big word real time. So what we have benefits for Edge is that we benefit from low latency data processing. That comes because our processing units, the edge devices, they're very close to the machines. They are there where data and where the magic happens. So that means the data doesn't have to travel around elsewhere. Second thing is, which is also important in correlation with drive systems, that we are able to detect or to analyze high-frequent data. Because high-frequent data means the data is coming in very short-term, and it's actually a very huge amount of data that is coming in. And sometimes it's only possible, or sometimes it's only needed to analyze certain parts of this. And the third big aspect of Edge is that you can ensure a secure manageability of all your devices at runtime. So Edge and Cloud, of course, they can do things both as well, but the differences in between their USPs, what these two systems bring with. Mm-hmm. So whether it's a use case for this long-term analytics, it's maybe better to use the cloud. But on the other hand, if you want to do on-site analytics, having to deal with high-frequency data, it's better to use the edge. Okay. But also, both can work together. Let's also keep this in focus.
Mm-hmm. All right, thanks. So we were talking about intralogistics. Is edge computing limited to special industrial segments, or are we talking about an endless field of possibilities here?
No, it's Christine, this is the compelling thing about it. Industrial edge can be used in a huge variety of vertical industries, starting in manufacturing industries and process industries alike. It does not only address general business and a mass market, but it also addresses customer and application-specific solutions. It offers a broad range of possibilities to customization. So that, as I already said, the machine builders, that system integrators, bring in their expertise to perfectly match the requirements of their specific customers and their specific use cases.
So talking about how to start with edge computing and talking about brownfield. Do our industry customers have to change their whole production lines or automation processes? And further on, which hardware and software products do they need?
So answering the first part of your question, Christine, do they have to change their whole production? No, they do not have to change their whole production. So that's the first cool thing about Edge, that it integrates to what you already have. Which hardware and software products do they need? Well, I assume that most of our customers, they already have working brownfield environments, brownfield production lines. So what they need to bring in is a so-called edge device. An edge device is typically for brownfield application. It's a kind of an IPC, for example. But also we will offer in the future edge-enabled automation devices. So meaning, for example, a PLC or an HMI panel or a drive system that has let's say the edge functionality already kind of onboarded. The second thing is, or the second step then, so to say, is that you connect this edge device to your machine. So on here we can benefit from an extensive connectivity capability. And the third step is to manage this device. And of course, if you just have one or two edge devices, you will think, why do I need a management for this? Trust me, the number of devices, it's growing and growing and growing. And then you are at a point where you say, I can't manage them one by one. I have to do it from one central point. And that's why we also have the edge management in place. Mm-hmm. The good thing about industrial edge is that, of course, you have an initial effort to set up the system itself, but you then have a cool life because you do not have to redesign or to reprogram and recertificate your PLC every time you want to extract a new data point or you want to analyze a new series of data points here.
The drive systems are really close to my heart, and therefore I need to point out here that also drive systems can be seamlessly integrated into this ecosystem, into industrial edge platform. It's the same platform, the same technology. Like the PLC, the drive systems are available throughout the complete platform. If you want to do edge computing, you don't have to change a lot. It's about using the drive data, operational data, which is already there in the required detail and quality. To get this data out of your drive systems, you don't need a lot. It's about three things, basically. It's our connectivity app, Drive System Framework, which ensures the integration of the electrical domain into the industrial edge. It reads in low and high frequency data. It allows for the management and the configuration of the drive systems. Second thing would be the mechanical domain, represented by our condition monitoring system C+CMS. It provides all the relevant vibration analytics to industrial edge already. It, if you will, brings in good vibrations to industrial edge. And thirdly, our edge application Analyze My Drives, which covers the visualization and analytics part, and with that allows machine users to get the overall picture, the in-depth understanding of their drivetrain, and with that of the machine.
So it's good vibrations, it's good life, it all sounds super, and it's all about using the drive data in the right way. But what exactly can you do with that large amount of data being generated?
Yeah, Christine, only collecting data does not help. It's an important piece, but it's not enough. Looking at the data, analyzing it, bringing structure to it, and transforming data to information, and eventually to intelligence. These three-level semiotics, this is the key to optimization.
Now that we know why edge computing is an essential technology and which benefits it offers, how does the near future look like?
Christine, it only just begun. We will connect all our drive systems and drivetrain components, even the mechanical domain, to the industrial edge platform. Together with our customers, we will implement further drivetrain examples and use cases, and with that, additional features in the future. This is our way to real predictive maintenance. We are providing the machine whisperer, the digital twin of the guts feeling of a machine operator into industrial edge, making the drive system, making the drive train a focal and crucial part of the overall solution that we are offering to our customers.
And Michael, maybe if you allow me to add another thing, everybody on the whole ecosystem, on the whole inference of industrial edge can benefit from these good vibrations, because industrial edge is more than just having ready to use applications and ready to implement use cases. It's also that you can bring in your own ideas. Because with the industrial edge ecosystem, we also enable everybody, really everybody, to develop and also sell your own applications. That means you, as a part of the ecosystem, you can just bring in your expertise, whether it's just a cool algorithm or just a cool way of representing things and processes. For you, it's easy to bring in exactly those insights quite easy. And also talking about algorithms, this is also a topic that I want to stress out a little bit more, because if we think about intelligent data processing, there is also the term of artificial intelligence that comes into place. And maybe as some of you have ever experienced or ever got into a little bit deeper into artificial intelligence, you find out that it's actually quite hard to overlook every component of an AI solution. But Edge again here can help to exactly lever and make it more easy to work with this new technology. And that is for me also the second big thing, and also a very good outlook for the future, that Edge makes it easier to work, that Edge makes it easier to bring in your ideas into the real. And yeah, that's it. That's what I think we will have in the future, more and more, this easiness.
Wow, this really is great. I like this idea of making artificial intelligence even more clever, smarter, and easier to access. So super cool outcome of this discussion. I think we could talk on and on and on, but time goes by really fast. I'm very sorry for that, as we have to close this for now. So thank you, Dominik and Michael, for being my guests and giving us these great insights into this topic today. For sure, there will be, as we have been talking about the future, there will be more sessions with the two of you. I'm certain for this. And of course, many thanks to our listeners too. I hope you all enjoyed this talk as much as I did. Dominik and Michael, thanks for being here with us and showing your insights.
Thank you, Christine. Thank you for giving me the chance to be here. Wishing all of you only good vibrations.
Only good vibrations. Cool term, Michael. Yeah, also big thanks from my side, Christine, for having us, for catching up all our extensive thoughts in such a short time. Yeah, there is only one thing left I want to say. Try it out. Implement things. Get your ideas into the real with Edge.
Word. Cool. So thanks to the two of you. And as usual, dear listeners, at this point, a few hints for further information where you can proceed your deep dive and contact the Drive Digitalization team on siemens.com/digital-drives. As always, Please don't forget to send us your feedback, questions, and more suggestions on which topic you'd like to hear more, as we are happy to provide more sessions on the topics which are interesting to you. So stay tuned for our next episode. This was Talking Digital Industries with Christine Brunner. Join us again soon. Stay healthy, safe, and curious.